Our study examined how age impacts performance within the lexical decision task. We hypothesized that within the lexical decision task we gave, older participants would have shorter reaction times than younger ones when recognizing words that older people know well, while younger participants would have shorter reaction times than older ones when recognizing words that younger people know well. The lexical decision task is a paradigm first introduced by Meyer and Schwanvelt in 1971. It was created to better understand how we retrieve information from long-term memory and how long-term memory can be organized. Can et al. Found that the frequency with which a word was presented and the age of the participant influenced reaction times and accuracy. Radcliffe et al. Also found that the participant's age influenced the participant's reaction times and accuracy. In that experiment, the older subjects who were ages 60 to 75 years old had slower reaction times than the young subjects who were college-aged. This article became the main basis of our experiment. We created our experiment through Side Toolkit software. Considering the lack of research in this area, it was hard to find words to serve as old and young words. We ended up using a table from Gerhand et al. To create a list of words that we presented. We adapted their early acquired words and late acquired words into young and old words. There were two independent variables in our study. The first independent variable was age group. Young participants were 18 to 44, and the older participants were ages 45 to 100. Our second was the type of word presented. The types of words shown in this study were old, young, and non-words that acted as our control. Our dependent variable was reaction time, which was measured in milliseconds. Recruiting was done through convenient sampling. Our final sample consisted of 35 participants. The age range was 19 to 69 years old. On the data collected from our experiment, we ran an independent samples t-test, which compared the difference in reaction times for young versus old groups. We found a significant difference between reaction times in old and young groups with a p-value of 0.013. The graph here shows age group on the x-axis and the difference in reaction times when subtracting reaction time for old words from young words on the y-axis. Our experiment is not perfect and certainly has some limitations. We had a small sample size, which lowered the power of our experiment. Our experiment was also not in a lab setting, so we could not control for environmental factors occurring near participants, thus decreasing our internal validity. We also had a limited scope of literature to work with, which led us to have to repurpose early acquired and late acquired words from Gerhand and Berry. In the future, we suggest that researchers who want to run similar experiments should develop a more empirically based list of words, including words that younger people know better than old people and vice versa. This will take some extra time and preparation that we could not afford. Another suggestion is to run the experiment in a more controlled lab setting with a larger sample of people. In conclusion, we confirmed our original hypothesis by finding that younger participants had a significantly faster reaction time for young words than older participants, and that older participants had a significantly faster reaction time for older words than younger participants.
Created using Powtoon.